Hello and welcome. Today we're looking at E2 elimination reaction mechanism, and it's presented to you by Science Visualized. In E2 elimination mechanism, we need a substrate, which in this case is an alkyl halide, and a base. And the product will always be a double bond. So it gives an alkene product. It's very important for E2 elimination that the leaving group, that's this bromine, and the hydrogen to be abstracted, that's H2, label 2 there, must have what we call anti-arrangement, so anti-periplanar. So for example, if you have something like this, if one group is going in, say bromine, then the other group must be coming out, the hydrogen. So that means you have about 180 degrees. So it's a trans relationship. We call that anti. If that condition is not satisfied, then the reaction will not go through E2. It will prefer to go through E1 elimination. Now let's look at the mechanism. The E2 elimination is a concerted reaction. That means all the steps occur at once. This is different from SN1 and E1, where the first step is the formation of a carbocation intermediate. In E2, you have a base which has a minus charge or electron pairs, and then it's going to abstract the proton that has the right orientation, which we said was the one labeled 2, and then at the same time the carbon-hydrogen bond will break, and those two electrons will flow to form a double bond between those two, between that carbon and that carbon, and then at the same time the leaving group will leave. Now we need to draw a transition state, and we do that by using square brackets, and then I'm just going to show the backbone of what we have there. We still have that blue hydrogen, nothing happens to it, and the red hydrogen that has the wrong orientation is still there, the one we labeled 1. But now you're starting to form a bond between that hydrogen, let me use the green, that hydrogen, a bond is starting to form between that and the base, because the base is abstracting that hydrogen. At the same time, the hydrogen-carbon bond is starting to break. At the same time, you're starting to form a double bond. And then at the same time, you're starting to break the leaving group. And then that proceeds to give you the final product, where now you have a double bond at that position. You still have the blue hydrogen, and you have the red hydrogen. And that is the elimination product. It's an alkene. In cases where you have more than one possible product, then you use Zaitsev rule, which we saw in E1 elimination. Review my presentation on E1 elimination on Zaitsev's rule. And Zaitsev's rule basically states that the most substituted alkene product is favored. So the most substituted is tetraalkene, which has 4 alkyl groups, 1, 2, 3, and 4. So 4 alkyl groups around the double bond, followed by trialkenes, which have 3 alkyl groups, followed by dialkenes, which has 2 alkyl groups, and then monoalkene, which has 1 alkyl group, and then lastly, ethylene, which doesn't have any alkyl groups. If you enjoyed this presentation, please consider subscribing. Thank you.